Good morning, children. I am Vijayalakshmi, Mathematics CRT, working at KVPALLE. Okay, ma, let us start. Already before session, we will discuss rational numbers, irrational numbers, and also introduce real numbers. Now, in this session, we discuss about irrational numbers and concepts of irrational numbers, representation of irrational numbers in the number line, like that. So, concepts of, now in this session, concepts. First of all, we discuss irrational numbers, and find the value of irrational numbers up to 6 decimal points by long division method. Next, representation of irrational numbers on the number line. Next, real numbers represent number line through successive magnification. In this session, we can discuss these concepts. One is irrational numbers, another one is find the value of irrational numbers up to 6 decimal points by long division method. Third one is representation of irrational numbers on the number line. Another one, real numbers represent number line through successive magnification. Okay, ma? Before session, we can discuss types of numbers. We can recall that concepts once again. That is rational numbers. Rational numbers are denoted by Q. And irrational numbers are denoted by Q dash. These rational numbers and irrational numbers together, that numbers are called real numbers. And real numbers which are not in real numbers, that is imaginary numbers, these two numbers together, that is complex numbers. Rational numbers and irrational numbers together, real numbers, which is not in real numbers, that type of numbers are called imaginary numbers. Real numbers, imaginary numbers together are called complex numbers. Now, in this session, before session, we can discuss rational numbers. Rational numbers also, it is denoted by Q. That means Q is quotient numbers. It is also called as quotient numbers. So that's why here we take rational numbers are denoted by Q. In this rational numbers, here also natural numbers and whole numbers and also integers. Integers are, this is the integers are genuine numbers. This is the tree diagram of types of numbers. This is the tree diagram of rational numbers. All types of numbers. Okay, ma? Now, in this session, first of all, we discuss irrational numbers. Before class, I will tell the definition of irrational numbers. What is the definition of irrational numbers? Which numbers cannot be expressed in the form P by Q, where P, Q are integers, Q is not equal to 0. That type of numbers are called irrational numbers. Which numbers cannot be expressed in the form P by Q? Okay, ma? This is the tree diagram of types of numbers. Then we discuss P by Q form numbers are decimal points. For example, 1.3. This is terminating. We already known as terminating decimals and non-terminating repeating decimals. Rational numbers are two types. Before class, I will tell us that one. One is terminating decimal, another one is non-terminating repeating decimal. 1.3, it is a terminating decimal. Now take another one, 1.3232 and so on. This one is non-terminating repeating decimal. Non-terminating repeating decimal. These numbers are we can express in the form of P by Q. These two decimal numbers we can express in the form of P by Q. So these are rational numbers. For example, we cannot express it in the form of P by Q. We cannot express it in the form of P by Q. For example, 1.316547102 and so on. This number is terminating? No. This number is non-terminating and also non-repeating. Non-terminating, non-repeating. So that's why this type of numbers are called as irrational numbers. These irrational numbers cannot be expressed in the form P by Q. Okay, ma? Did you understand this one? Next. So, which numbers can be expressed in the form of P by Q? That numbers are rational numbers. Which numbers cannot be expressed in the form? That type of numbers are called irrational numbers. In these irrational numbers, we can express not perfect squares. Not perfect squares. Here, use the Pythagoras theorem. This Pythagoras theorem we can learn in 10th class. Learning in 10th class. Now we briefly explain Pythagoras theorem. Here we take isosceles right angle triangle. Okay, isosceles right angle triangle. See here, this is 90 degrees. This is 1 unit. This is 1 unit. So this is 1 unit and 1 unit. Isosceles right angle triangle. In this isosceles right angle triangle, which is opposite to right angle, that side is called hypotenuse. So Pythagoras theorem, this is hypotenuse. Hypotenuse means h. This is one side and this one is another side. Both in isosceles triangle, two sides are equal. Using Pythagoras theorem, hypotenuse square is equal to side square plus side square. That means in Pythagoras theorem, square of hypotenuse is equal to sum of the squares of the other two sides. That is Pythagoras theorem statement. The statement of Pythagoras theorem is hypotenuse square is equal to sum of the squares of the other two sides. That is the statement of Pythagoras theorem. So here hypotenuse square h square and other two sides square. One is s square and another one also s square. Sum means we can add this both two sides measures. Okay ma, h square is equal to s square plus s square. For example, here this is 1 unit, this is also 1 unit. Then 1 square plus 1 square. 1 square means 1 value and 1 square is also 1 value. 1 plus 1 here 2. H square is equal to 2. Then h is equal to square root of 2. 2 square root of root 2 is not a perfect square. Root 2 is a irrational number. That means root 2 value is non-terminating, non-repeating decimal. Okay ma? Non-terminating, non-repeating decimal. So root 2 is identified in irrational numbers. Root 2 value is non-terminating and non-repeating decimals. We cannot express in the form of p by q. Root 2 is not expressed in the form of p by q. That's why root 2 is irrational number. Okay ma? This is Pythagoras theorem. We can learn in 10th class, next class also. I will briefly explain here. Then in this irrational numbers, some perfect squares is there and all numbers you can take root. For example, we cannot express square roots. Square roots ni find out చేస్తూ irrational numbers ni, irrational and rational numbers ni ఎలా చేయడం, how to express root 2 values and root 3, root 4, root 5 values. Square roots find out చేసి మనం find out చేయాలి. Then let us discuss about this concept. For example, root 1. Root 1 value plus or minus 1. And you take root 2. What is the value? You don't know. That is non-terminating, non-repeating decimal. Then root 3 and root 4. What is the square root of root 4? Square root of 4, that is plus or minus 2. And root 5, root 6, and root 7, and root 8, and root 9. Root 9 square root of 9, that is plus or minus 3. So in these numbers, root 1, root 4, root 9, these are rational numbers. It can be expressed in the form of p by q form. Next, root 2, root 3, and root 5, root 6, root 7, root 8. These are irrational numbers. These are irrational numbers. In these irrational numbers, we can find out a value. How to find out? Here we take long division method. We can take long division method. Then we can find root 2 value and root 3 value, root 5 value, root 7, etc. and so on. This type of irrational numbers, we can find out the values by using long division method. In normal division, we can take any tables. We can find out the normal division. But here, in long division method, we can use only perfect squares only. We can use only perfect squares and find the root 2 and root 3, root 5, root 6, root 7 values. Okay ma? In this root 2 values, first we can take root 2 value. To find root 2 value by using long division method. Okay, here it is 2. rational number. 2 is a rational number. Here you take decimal point to point. After point, decimal point, to take any zero, there is no value of zeros. Here we find root 2 value up to 6 decimal points. Up to 6 decimal points. This is long division method. You can already learn in 8th class. You can already learn in 8th class now. Okay. Once recall the perfect squares. In 8th class you already learned which numbers. For example, I will take one number. This is one rational number. This is one rational number. You can find out this number by using long division method. In this long division method, every 2 digits right of the unit place. Right of the every 2 digits right from unit digit bar. You can use bar. Right from unit digits. So here we take 10 bar and 24 bar. In this long division, we can take only perfect squares. That means 1 square 1, 2 square 4, 3 square 9, 4 square 16. These perfect squares values are we use in this long division method. Okay, ma? Here first 10 is there. So which is the nearest and also smaller than 10? That means 2 2s 4, 3 3s 9, 4 4s 16. So 9 is the smallest of the 10. So that's why here we take 3 3s 9. Then 10 minus 9, 1. In normal division, we will put only single digit. We can put single digit. But here in long division method, we can put total which number is bar, that 2 digits are take down. 124, 124. Here quotient is 3. Here quotient is 3. Then we take here twice of the quotient. Twice of the quotient. Here 3 is there. Twice of the 3. That value is here 9. Then you put here another 1 digit. You can take any digit. The total digit. Here also same digit you can take. The total digit is divided multiplication by this one. For example, I will take 91. Okay, I'm sorry. Here 3 twice 6. 3 twice 6. 3 plus 3, 6. Okay, here I will take 1, 61, and here also take same number. 61 ones, 61. This is very smallest number of 124. So that's why here we take another one. That is second one, 62. You take same digit number in the quotient. 62 twos. How much? 62 twos. How much more? 2 twos are 4. 2 six are 12. Then remainder is 0. Then square root of 1024 is equal to 32. So same way you can take 2 irrational number of square root of 2. Then you find out the long division method by using long division method to find the value of 2. Okay, ma? Let's here also we will put every 2 digits right from the units place take bar. Okay, ma? Here 2 digits. Here 2 digits. 2 digits. 2 and 2 and 2. Here also only single digit, that is 2. You can take 2. Then here you take 1 ones. 2 is there. So that's why this is the smallest perfect square here. 1 is the smallest perfect square. 1 is the smallest perfect square. Here basic calculations compulsory. You can take basic calculations, that is multiplication, divisions and nearest perfect squares and guessing method. And also guessing method is very important in this long division method. Okay, so here 2 is there, so that's why 1 ones 1. Then you multiply 2 minus 1. Then what is that one? 1. So quotient is 1. Then you take here which number? Twice of the quotient. Twice of the quotient. 1. 1 twice number is 2. Then we need another one digit here. For example, I will take 21. Then you put quotient also same digit 1. Okay, ma? Did you understand that one? Which number you take here? Same number also. We take in quotient also. ఏ నెంబర్ అయితే మనము ఇక్కడ తీసుకుంటామో సేమ్ నెంబర్ ని కోషంట్ లో కూడా అదే నెంబర్ తీసుకొని ఈ టోటల్ డిజిట్ ని మల్టిప్లై చేయాల్సి ఉంటుంది. ఓకేమా? సో హియర్ పుట్ డౌన్ these two zeros. Here is 100. Then you take here 2, and for example here is decimal point. Then you put in quotient also decimal point. 22 2s are how much? 44. 44 is the smallest, very smallest of 100. Then you take another digit 23. That means 23 threes. How much, ma? 23 threes. 3 threes are 9. 3 twos are 6. This one also. This one also. Smallest. You take 24. 24 fours are. 4 fours are 16. 4 4 twos are 8. 9. So here you take 4 and 4. So this way, this process you can take to continue the long division method. 24 fours are. Which number you can take? ఏ నెంబర్ అయితే ఇక్కడ తీసుకుంటారో సేమ్ నెంబర్ కోషంట్ లో తీసుకొని అదే నెంబర్ తో మల్టిప్లై చేయాలి. ఓకేమా? 24 into 24. 4 fours are 16 and 1 balance is there. 4 twos are 8 and 1 9. So 96. Then you subtract this one. The value is borrowing method. Borrowing subtractions. You know that one. Then 10 minus 6. How much value is 4? And 9 minus 9 0. Then you can take, say, another, put down another decimal numbers 0 0. Another pair of decimal numbers. Then you can take here. See here, what is the quotient number? 1 4. That means 14. Then twice of that number. 14 twice how much, ma? 28. Then you take here. Same. ఇక్కడ ఎలా అయితే చేసామో సేమ్ వే హియర్ ఆల్సో ఇక్కడ కూడా అలాగే చేయాలి. 28 పక్కన ఏ డిజిట్ అయితే మనం తీసుకుంటామో which number you can take here? సేమ్ డిజిట్ ని కోషంట్ లో తీసుకొని ఆ కోషంట్ లో ఏ నెంబర్ అయితే మనం పెడుతున్నామో ఆ నెంబర్ తో ఈ టోటల్ డిజిట్ ని మల్టిప్లై చేసి ప్రోడక్ట్ ని ఇక్కడ తీసుకుంటాం. ఓకేమా? దిస్ ఇస్ 400. Then you take here 1. For example 1 281. 281. Then you take in quotient. So quotient lo which number you take? Quotient lo compulsory you take one number. So 281 ones. 281. 282 twos. Compulsory it will get largest, biggest number of the 400. That's why here we take 281 ones only. Then 10 ones are 10 minus 1 9. Borrowing subtractions you take borrowing subtractions. 9 minus 8 1. Here 3. 3 minus 2 1. Then you take another zeros here, 0, 0. Okay, ma? Did you understand this one? Then same. In quotient 141, that means 141. 141 twice number, that is 2, 8, 282. Then you take, here we need another one digit. Here we need another one digit. Guessing method. For example, here 3 digits is there. You can put another one digit. Total 4 digits. Then you take 4 digits. Here we use guessing method. 4 digits, that is 1190. 1190. It is approximately equal to 1200. So we can take 1200. Here 4 digits. 4 digits. Put another one digit. This is 4 digits. That is 2821 or 22, anyone. So this is 282. Approximately 300. Nearest number is 282. Nearest number is 300. Okay, ma? I will take here 300, 3 digit number. So 2 zeros, 2 zeros, 3 ones, 3 fours are 12. So you take how many times here? 4 times. Then you put in quotient here also 4. Exactly this guessing method. You take 5 here, 2825 5s. It will, that product is biggest of this number. So that's why you can put here 4. Compulsory ఇక్కడ 4 ఎందుకు తీసుకున్నామంటే 4 తీసుకుంటే ఇక్కడ ఉన్న నెంబర్ కంటే స్మాలెస్ట్ నెంబర్ వస్తుంది. ఫర్ ఎగ్జాంపుల్ ఇక్కడ మనం 5 తీసుకున్నాం అనుకో 2825 5s are product compulsory, it becomes largest number of this number. So that's why here we take 4. Then 2824 into 4. 4 4s are 16. 1 remaining. 4 2s are 8. 1 9. 4 8s are 32. Balance is 3. 4 2s are 8. 8 plus 3 11. So here 11,296. This is the smallest of 11,900. Then you take borrowing, subtraction. 10 minus 4 6 4. 9 minus 9 0. And here 8 minus 2 6. 8 minus 2 6. Then you take another, put down another 2 digit numbers, that is 0 0. Okay, ma? Then you take here 4 digits. In quotient 1414 is there. So that's why here you take which number, ma? Twice of the quotient. 2 8 2 8. Here we need another 1 digit. Here we need another 1 digit. Okay, ma? Then here you take 4 digits. 4 digits. That is 2828. 2828. Here you take 4 digits. That is 6040. So 2828 is nearest number is 3000. 6040 nearest number is 6000. So here you take one is 6000, another one is 3000. Then here cancel this one, 3 ones, 3 twos. Then how many times it can division? 2 times. So you take here 2 times. This is guessing method, ma. Okay, ma? This is guessing method. You guess approximately which number is nearest product. Okay, ma? So here 28,282. Here also we put 2. Then 2 twos 4. 2 8s 16. 1 is there. And 2 twos 4 plus 1 5. And 2 8s are 16. 2 twos 4 and 1 5. Here we can find up to 6 decimal points. Here we can find up to 6 decimals. Here 1, 2, 3, 4 is there. So another 2 digits we can find out the quotient number. Then here you take borrowing subtraction. 10 minus 4 6 and 9 minus 6 3 and 3. Borrowing method 13 minus 5 8 and here is number is 9. 9 minus 6 3 and 5 minus 5 0. Then you take another pair of zeros. Okay ma? Then here you take quotient. Which numbers in there? Quotient 14142. That means 14,142. You take twice of the quotient 2, 8, 2, 8 and 4. We need another 1 digit. Another 1 digit. So here 5 digits is there. 5 digit number. That means 28,284. You take here also 5 digits. 38,360. It is nearest. 38,360 nearest number is 40,000. Here 28,284. Nearest number is 30,000. Then you take 40,000 divided by 30,000. Here 38,360 nearest number 40,000 and 28,284 nearest number is 30,000. Okay ma? Here 4 zeros cancel and 3 is not perfectly divided here. But only 1 times 3 ones 3. 1 point something is there. So you can take 1. So that's why here we can take 1. Then here also 1. Okay ma? Then you take 28, 28, 41 number is there. That is the nearest product of that one. So borrowing subtraction 10 minus 1 9 and here also 9 minus 4 5 5. Borrowing method 15 minus 8 7 and 2 minus 2 0 8 minus 8 0 3 minus 2 3 minus 2 1 1 0 0. Then you take another last 2 zeros. Okay ma? You take same quotient numbers 1 4 1 4 2 1. Twice of the quotient. Here you take 2 8 4 2. We need another 1 digit. That means take here how many digits? 1 2 3 4 5 6 digits is there. That means 2,82,000. 2,82,842. This number approximately nearest number is 3 lakhs. Okay ma? 2,82,842 approx number is 3 lakhs. Same way here 10 lakhs. Here also you take 10 lakhs. 10 lakhs. 10 lakhs 7,599 something is there. So here also you take only this 6 digits. 6 digits. Then you take 10 lakhs. Nearest number is 10 lakhs. Here nearest number is 30 lakhs. 30 lakhs or 3 lakhs? Only 3 lakhs ma. So 10 lakhs divided by 3 lakhs. 10 lakhs divided by 3 lakhs. Then here 5 zeros cancel. Then this one is divided in 3 point something is there. So how many times here divided that one? 3 times. Then you take here 3. Here also you take 3. So this is the long. You can continue this process. Then you can take that number is non-repeating or non-terminating. This process you can continue. Various numbers you can take in quotient numbers. Okay ma? So what is the value of root 2 here? Root 2 is equal to 1.414213 and so on. But in this method, we can take only up to 6 decimal points only. That's why here we can take 2 value is 1.414213. Okay ma? This is the long division method. Did you understand this one? Root 2 is a irrational number. Root 2, we find a long division by using long division method. To find the value of root 2 is equal to 1.414213. This is non-repeating, non-terminating decimal. Okay ma? Next, you can take another topic. Representation of irrational numbers. Representation of irrational numbers. Okay ma? Same method. You can take same long division method and find the value of root 3 and root 5 and root 7 and so on. Root 3, root 5, root 7 and so on. You can find out these values also by using long division method. Next, representing irrational numbers on a number line. Representation of irrational numbers on a number line. Very important thing is here Pythagoras theorem. Using by Pythagoras theorem. And identify root 2 on the number line. We can also learn and also I will explain before topic Pythagoras theorem. That is, I would take here isosceles right angle triangle. Isosceles right angle triangle. This is 1 unit. This is 1 unit. This is square root of 2. How it is possible? How it is possible? Using hypotenuse square is equal to sum of the squares of the other two sides. Using by Pythagoras theorem. Hypotenuse square, we don't know here. For example, this is H hypotenuse. Here is 90 degrees angle. Which angle is opposite? Which side is opposite to 90 degrees? That side is hypotenuse. Hypotenuse square. That is 1 square plus 1 square. That is equal to 1 plus 1, 2. H square is equal to 2. Then H is equal to square root of 2. This is using by Pythagoras theorem. We can represent irrational numbers on the number line. Okay ma? Now, number line, you know number lines. Natural number line, integers number line, whole numbers number line. Now let us take integers number line. First, draw a number line. First, draw a number line. Here, which concept we can explain here? Representing root 2 value on a number line. Representing irrational number. That is root 2, root 3, root 5, root 7 and so on. I will take here root 2 value. Locate root 2 on number line. First of all, we can draw a number line. Then, equal distance. Each one is in equal distance. We can take equal distance ma. Here also. Here. This is minus 1. Left side of the 0, negative numbers. And right side of the 0, positive numbers. Each unit is in equidistance. Then let you draw. First of all, this is point O, and here this point is A. Then you can take OA line. Then you take one perpendicular line of OA. That is AB. AB. This one also take 1 unit. This one also take 1 unit ma. This point is B. This point is B. Let Draw AB perpendicular. This symbol is perpendicular symbol, na? AB perpendicular OA with 1 unit. With 1 unit. Let draw AB perpendicular OA with 1 unit. Then join OB. Then join OB. It is a right angle triangle. It is a right angle triangle. Then in triangle AOB, in triangle AOB, in triangle AOB, here this is 1 unit, this is 1 unit, and this one also 1 unit. You take both sides same 1 unit, ma. According to Pythagoras theorem, in this isosceles right angle triangle, according to Pythagoras theorem, here which one is hypotenuse here? Which side is opposite to 90 degrees? Here right angle here, opposite side is this one, that is OB. By use according to Pythagoras theorem, using Pythagoras theorem, hypotenuse square, that means OB square is equal to OA square plus OB's AB square. OA square plus AB square. OA value is 1 unit and AB value is 1 unit, that is also 1 square, that is 2. Then OB square is equal to how much value? 2. Then OB is equal to square root of 2. So OB value is square root 2. So this is the measure of OB. Measure of OB. Then you can take by using compass. By using compass with radius OB, center of O, we can take radius AB. OB radius. OB is the square root of 2. Then you can draw one arc. You can draw one arc with radius OB. It bisects the number line. This point is, take C. C represents root 2 value. C represents root 2 value. So here in triangle AOB, using Pythagoras theorem, OB is equal to root 2. Then you take OB radius, can draw one arc with radius OB. OB bisects number line in C point. C represents root value, root 2 value. C represents on number line, that is the root 2 value. Okay ma, this is the root 2 value represent or locating on the number line. C is the point root 2 value. Okay ma. Same way here also, for example, we take any one of that one. For example, you take another value root 3. So same way here we can draw one perpendicular line on AB with the measure is 1 unit. With measure is 1 unit. For example, I will take AB. This is also 1 unit ma. This is D. Perpendicular line of AB. Perpendicular line of AB. OB, perpendicular line of OB. This is 1 unit D. Then join. Here also join O D. First of all, ఇక్కడ మనం ఫస్ట్ OA 1 యూనిట్ AB 1 యూనిట్ OB జాయిన్ చేసాము. OB using Pythagoras theorem, OB value is √2. then OB value √2 తీసుకొని మనం యూజింగ్ కంపాస్ OB రేడియస్ తో O సెంటర్ గా తీసుకొని 1 ఆర్క్ డ్రా చేస్తాం. దట్ పాయింట్ is C. C represent √2 value. Next you take OB perpendicular line BD. OB perpendicular line BD. Okay ma? Then here this one OB measure is here in triangle OBD or BOD. You take any one triangle BOD. In triangle BOD, right angle triangle BOD. Here OB measure is √2 and BD measure is 1. Then you can find out OD. Okay ma? By using Pythagoras theorem. Here also, here 90 degrees is there. Opposite side OD. How OD is? Hypotenuse. Then OD square. By using Pythagoras theorem, OD square is equal to OB square plus BD square. By using Pythagoras theorem. Then OB, what is the value of OB? Here √2 whole square. Then BD is 1 square. Here square is square root cancelled. Then value is 2. 2 plus 1 square value is 1. Then OD square is equal to 3. Then OD is equal to square root of 3. So OD value is, OD measure is √3. Here also same way you can take √3 value measure of OD. You can take OD with radius OD. Then you can draw center O and draw one arc here. This is the value of this arc bisects the number line here ma. This is the value. This is E. You can take this point. You can take this point E. This is E represents √3 value. E represents √3 value. Okay ma, did you understand how to represent √2 and √3? We can continue this process. Then you take √4 and √5, √6 and √7 also. Okay ma? This is represent irrational numbers on the number line. Next, let us locate another one, that is √5 minus √5. √5 and minus √5. Locate √5 and minus √5. How to represent number line? √5 value and minus √5 value. Okay ma, take another one also. Here √5, which is the perfect nearest number of √5? For example, 1 square 2 and 2 square 4, 3 square 9. 3 square 9. 9 is greatest one and 2 square 4 is smallest one. That is the nearest of 5. That means 4 square root of 4 is 2. Okay ma? Square root of 4 is 2. For example, you take any √n number. √n number locate on the number line. We must know the position of, compulsory we must know the position of √n minus 1. For example, you can take √3 value. Then you can know the position of, compulsory you take √2. That means 3 minus 1, √2 value. For example, you take √7, locate on the number line. Then we must know the position of √6. For example, you take √10. Then we must know the position of √9 on the number line. Okay ma? First of all, here you take √5 and minus √5. Then we must know the position of √4 also. √4 is a perfect square. The value of root 4 is 2. So that's why here you take how many units here? 2 units. Okay ma? First draw a number line. Draw a number line. 0 and 1, 2, 3. Here also -1, -2 and -3 and so on. This is 1, 2, 3. Here you take first root 5. Root 5 is a positive, that means left side of the right side of the 0 and minus root 5 is left side of the 0. Here root 5 position of we know the position of root 4. Root 4 is perfect square. That means for example అంటే root 5 అనేది locate చేయాలి నెంబర్ లైన్ మీద. root 5 locate చేయాలి అంటే కంపల్సరీ we must need root 4. దానికి ముందున్న నెంబర్ యొక్క లొకేషన్ మనకి తెలుసుకోవాలి, పొజిషన్ తెలుసుకోవాలమ్మా కంపల్సరీ. ఓకేనా? root 5. So we must need position of root 4. So that means root 2. Root 4 position is 2. So here you take this one is O and this is A. That means 2 units. Here you take 2 units. That means root 4 value is 2. That's why here you take 2 value. Then you take perpendicular. AB perpendicular B. This number is B. And join OB. Join OB. So here AB 1 unit. This is B. AB 1 unit ma. OA 2 units. We need OB value. By using Pythagoras theorem, hypotenuse square is equal to side square OA square plus AB square. Then OB value is we don't know. OA 2 units, that means 2 square, plus AB 1 unit, that means 1 square. 2 square value is 4 and 1 square is 1, that is equal to 5. So OB square is equal to 5, then OB is equal to square root of 5. So this is root 5. Then you take measurement OB. OB is the radius. Root 5. Then put center of O. Then take another arc. OB is the radius. Then draw an arc. It bisects number line. This is the value C. This is C represents here root 5. C represents root 5 value. Okay ma? This is root 5. Then you take minus root 5. It is in left side of the 0. Here also same way. Root 5 position. You know that one. So here P value. This is O. And you take 1 unit. Here also same. Perpendicular. PQ perpendicular to OP. Then you join Q and O. Here also by using Pythagoras theorem, this is 90 degrees. Opposite side OQ square, that is hypotenuse, and PQ square plus OP square. PQ here 2 units. Minus 2, that means minus 2 square. Okay ma? Here OP. Here how many units here? This is minus 2 units. That means here minus 2 whole square and 1 square. Minus 2 whole square, that means 4 plus 1. 4 plus 1, 5. So OQ square. OQ is equal to root 5. So this is also minus root 5 value. Minus root 5 value. Here also you take OQ radius. And draw one arc here using by compass. Then the value. This arc bisects number line, that is R. You take R. This is the point. R point represents minus root 5 value. Okay ma? Draw an arc with OB radius. Here OB radius. Here OQ radius. Then you take, this is minus root 5. R represents minus root 5 and here C represents root 5 value. This is a representation of irrational numbers on the number line. Okay ma? Next one. For example, you take any two irrational numbers. You take any two irrational numbers. Note here, an irrational number between A and B. An irrational number between A and B is root AB. This is the formula to find the irrational numbers between any irrational number. For example, you take any irrational numbers. Rational numbers or irrational numbers. Okay ma, I will take here for example 3. Here AB is not a perfect square. AB is not a perfect square. Here note, listen carefully. An irrational number between A and B is root AB. An irrational number between A and B is root AB. AB is not a perfect squares. AB is not a perfect squares. For example, I will take 3 and 4. Then you take here 3 into 4. That means root 12. Then why you take AB is not a perfect squares? I will take for example, this one is 6. This one is 12. 12, 4. For example, A is equal to 4 and B is equal to, A is equal to 3 and B is equal to 12. These two are irrational numbers. Rational numbers. Then you take A into B. 3 into 12, that is equal to 12 3s are 36. Root 36, that is it, plus or minus 6. So that's why here you take AB is not a perfect squares. AB is not a perfect squares ma. This is to find an irrational number between any two rational numbers ma. Let us next you take real numbers. Real numbers you can already once we call it real numbers. Real numbers means tree diagram of real numbers, that is rational numbers and irrational numbers, union of rational and irrational numbers. That numbers is called irrational numbers. In rational numbers, here also two types. One is terminating, another one is non-terminating, repeating decimal. Non-terminating, repeating decimal. One is terminating, another one is non-terminating, repeating decimal. So these are union of rational and irrational numbers is called real numbers. Here real numbers means you can take any real number, that means non-terminating, non-repeating decimals. Non-terminating, non-repeating decimals or terminating decimals. You can take any decimal representation on a number line through successive magnification. Now the topic is representing real numbers on the number line through successive magnification. Successive magnification. Here we use magnifying glass. That means both of them antaru kada. That is magnifying glass using each unit divided it into 10 equal parts. Then using representing real numbers on the number line through successive magnification ma. Okay ma, let us start that one. First we can draw one number line. First of all, we will take one decimal number, that is 2.776. 2.776. It is terminating decimal. It is terminating decimal. Okay ma? First of all, we can draw a number line. 0, 1, 2, equidistance. Each unit is in equidistance. 5, 6, 7, 8, 9. Okay ma? First of all, take 2.776. 2.776. 2.776. So this number is between 2.776. 2 and 3 numbers. Here this is 2 and 3. Here we take magnifying glass. Here we take magnifying glass. That means both of them. Here 2, 3. How many equidistant numbers here? These 1 unit we can divide it into 10 parts, 10 equal parts. Okay ma? That's why here we take another number line. That is here 2. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This is 3. So in between 2 and 3. In between 2 and 3, here 10 equal parts is there. That is 2 and 3 between numbers. So here we put 2.1, 2.2 and 2.3, 2.4, 2.5, 2.6, 2.7, 2.8. This is 2.9 and 3. Now see here 2.776. It is between 2.7 and 2.8. 2.776 between 2.8 and 2.7. Okay ma? So now here we using magnifying glass. Magnifying glass. Here also we take number line. This is 2.7. Then 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This one is 2.8. Here how many decimals is there? 3 decimals. Then here also you will take 3 number lines. So this point is అర్థమవుతుందమ్మా? Here ఇక్కడ మనము 2 కి 3 కి between number 2.7. ఫస్ట్ ఆఫ్ ఆల్ 2.776 ఎక్కడ ఉందో అబ్జర్వ్ చేసుకోవాలి. తర్వాత ఎక్కడ ఉంటే అక్కడ మాగ్నిఫైయింగ్ గ్లాస్ యూస్ చేస్తున్నాం అంటే భూతత్వం ఏం కనిపిస్తుంది మనకి? అక్కడ ఉన్నది కొంచెం పెద్దదిగా కనిపిస్తుంది కదా? సేమ్ ఇక్కడ కూడా 2.7 కి 2.8 కి ఉన్న బిట్వీన్ నెంబర్స్ ని మనము భూతత్వంలో పెట్టి చూస్తున్నాము. అందువల్ల మాగ్నిఫైయింగ్ గ్లాస్ యూస్ చేసి మాగ్నిఫికేషన్ అని చెప్పడం జరిగింది ఇక్కడ. ఓకేనమ్మా? 2.71. This one is 2.72 and 2.73. This is 2.74, 2.75, 2.76 and 2.77, 2.78, 2.79 and this is 2.8. See here 2.776 between number is 2.77 and this is 2.78 between number. This is also magnifying glass take. So here also take another maroka number line draw chestuntam. Ikkada 2.77 and 2.78 points ki between numbers. This is 2.77. This is 2.7. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This one is 2.78. Okay ma? Now we can take this one is 2.771, 2.772, 2.773, 2.774, 2.775, 2.776, 2.777, 2.778, 2.779. So which number here? 2.776. So here it is. This is 2.776. This is the number line to represent by using magnification method, successive magnification method to find the non-terminating or non-repeating decimals in the number line by using successive magnification. Okay. Next, in this class we can learn irrational numbers. We can learn irrational numbers and the irrational numbers represent on the number line and real numbers representing on the number line by using successive magnification. So ఈ క్లాస్ లో మనం ఏం నేర్చుకున్నాము? irrational numbers definition and irrational numbers represent on the number line. irrational numbers ని number line లో ఎలా represent చేయాలి? నెక్స్ట్ irrational numbers, rational numbers అన్ని real numbers ని సక్సెసివ్ మ్యాగ్నిఫికేషన్ యూస్ చేసి ఎలా రిప్రజెంట్ చేయాలా నెంబర్ లైన్ లో అనేది చూసాం. దిస్ ఇస్ ద క్లాస్ నౌ. I will, okay ma, this is your home assignment. Next class we will discuss about operations of real numbers. Now we can write down the assignment. ఈ అసైన్మెంట్ రాసుకొని కంపల్సరీ మీరందరూ ఇంటి దగ్గర కూర్చొని రాసి మీ వాట్సాప్ నెంబర్స్ లో మీ టీచర్స్ కి సెండ్ చేయాలమ్మా ఇవి. ఓకేనమ్మా? దెన్ రైట్ డౌన్ అసైన్మెంట్ 2. This is second class, second session. So this is assignment 2. Before class, I will tell assignment 1. That is, so first problem. Find the value of root 2 and root 7 by using long division method. Second problem. Locate root 10 on a number line. Next, third one. Find at least 2 irrational numbers between 2 and 3. Next problem, fourth one. Activity ఉంది మా square root spiral అని పేజ్ 15 లో టెక్స్ట్ బుక్ ఉంటే చేయండి. పేజ్ 15 లో యాక్టివిటీ square root spiral టెక్స్ట్ బుక్ ఉంటే చేయండి. ఓకే, లేటెస్ట్ లీవ్ ఇట్. లేకుంటే క్లాస్కి వచ్చినాక నేర్చుకుందాం. ఓకేమా? నెక్స్ట్ ఫిఫ్త్ వన్. Visualize 2.874 on the number line. By using successive magnification. Okay ma? This is the second class. Now we will meet again third session ma. Bye students.